Wow, look there. They are playing tug of war. Looks like both sides are pulling equally.
Mama, this cart isn't moving.
Push it harder, Mina.
Mama, why are you leaning to one side?
Baba, how does this bridge hold up all the bikes and people without falling? Whoa! Did you see that shot? And that block? That's some real force action.
Hello kids! I'm Captain AHS. Today, we're going to discover the difference between balanced and unbalanced forces and how they affect the motion of objects.
Wow, look there. They are playing tug of war. Looks like both sides are pulling equally.
That's called a balanced force. When two equal forces pull in opposite directions, they cancel each other out. No one moves.
So even though they are pulling, the rope isn't moving because the forces are the same?
Exactly. It's balanced, the rope stays still.
How they can move the rope?
Only when one side pulls harder, so the forces will not equal, and that's an unbalanced force.
So, unbalanced means something changes, like speed or direction.
Right. An unbalanced force can make things start, stop, or turn.
So a soccer ball on the ground stays still, but if I kick it?
That kick is an unbalanced force. Great thinking, Sorrow.
Mama, this cart isn't moving.
Push it harder, Mina.
Wow, it moved now.
That's because you push it harder and the forces aren't balanced. And did you know? In tug of war or soccer, when one force is greater, we say the net force is not zero.
Net force means the total force? Like adding all the pushes and pulls?
Yes. If they balance, net force is zero. If not, movement happens.
Mama, why are you leaning to one side?
Because one side bags has all the fruit, and they are heavier. The forces on both sides aren't equal. That's called an unbalanced force, and it's pulling me down towards one side.
So, if both-sided bags were of the same weight, would that be a balanced force?
Exactly. Then I wouldn't tilt at all. My body would stay in balance.
So grocery bags can teach us about science too.
Baba, how does this bridge hold up all the bikes and people without falling?
That's engineering, Mina. Engineers use their knowledge of balanced forces to make sure the forces on the bridge stay even, so it doesn't bend or break. They calculate how strong the support beams need to be, how much weight it can hold, and where the forces push and pull.
Whoa! Did you see that shot? And that block? That's some real force action.
Totally. When the player kicks the ball, that's an unbalanced force starting the motion. When another player stops it, another force acts in the opposite direction. In sports, players constantly use unbalanced forces to start, stop, or change direction.
So cool. Forces make soccer fun and tricky.
Whoa! Did you see that rocket launch?
Now that's where forces really take off, literally. Rocket launches use a strong unbalanced force pushing down on the ground so the rocket goes up. That's Newton's third law in action.
And satellites in space? Are they using balanced or unbalanced forces?
Once in orbit, they stay balanced, gravity pulls them toward Earth, but their speed keeps them moving forward in a curve. It's like a constant tug-of-war.
So engineers, athletes, and astronauts all use these force ideas in real life.
Exactly! Balanced and unbalanced forces aren't just science words, they shape how bridges stand, how sports are played, and how rockets fly.
Now it's the time for quiz. Are you ready for a fun quiz to test what you've learned about balanced and unbalanced forces? Let's see if you've got what it takes. It's quiz time! What happens when both teams pull with equal force in tug-of-war? A. The rope moves fast. B. The rope stays still. C. The rope disappears. The correct answer is B. The rope stays still. When two teams pull with equal force in opposite directions, their forces cancel each other out. What is an example of an unbalanced force? A book resting on a table. B. Two people pushing equally on a door. C. One side pulling harder in tug-of-war. The correct answer is C. One side pulling harder in tug-of-war. An unbalanced force occurs when forces aren't equal, like when one side pulls harder in tug-of-war. What helps the toy cart roll down the hill? A. Light from the sun. B. Balanced forces. C. Gravity and a push. The correct answer is C. Gravity and a push. Gravity pulls the cart downhill, and a gentle push starts it moving. What does net force mean? The amount of air in motion. B. The total of all forces acting on an object. C. The direction of wind force only. The correct answer is B. The total of all forces acting on an object. Net force is the vector sum of all forces on an object. What keeps a bridge from falling down under weight? A. Lucky guesses. B. Balanced forces and engineering. C. Strong wind. The correct answer is B. Balanced forces and engineering. Engineers design bridges so that upward support and tension balance the downward weight. Next time, we'll take our learning a step further and see exactly how balanced and unbalanced forces change the way things move. It's going to be full of motion and discovery. Don't miss out on more free, interactive lessons. Hit subscribe and join us on the journey to education without boundaries.